everybody. Today I want to talk to you about common mistakes that I see people using when it comes to logs. And I get it, there's a ton of log rules and they look strange sometimes, and so people tend to mix them up. So they're in no particular order, it's just these are super common things that I see that I wanted to address, and hopefully with just a little bit of clearing this up, you won't be making these mistakes. And mistakes are our friends. If you make mistakes, that's fine, but you just gotta make sure that you learn from them. So here's the first very common mistake that I see. People using a quantity that's inside of a log, like x plus 2, and separating them and writing them as log of x plus log of 2. And that is just not done here. And so let me give you an example. When something is inside of a log, it's inside of that function. So for example, it's like saying the square root of 2 plus 3, which is the square root of 5. That is inside of the square root function. That is different than a separate square root of 2 plus square root of 3. So square root of 2 plus square root of 3 is not going to be equal to the square root of 5. So you can't do that. So likewise, you can't do that with logs either. So we want to make sure that we keep those guys separate. So just make sure that you're seeing, what is inside of the log. And you're always welcome to use the parentheses just to indicate that something's in a log. Sometimes we do and sometimes we don't as mathematicians. So you'll see that, about half the time people are going to use the parentheses. They're there for clarification purposes. So here's the next very common mistake, and that is people confuse these two and they think that they're equivalent statements, and they are not. So we know we do have a power rule that says that if you had, for example, an x squared inside of a log, you could take that exponential power and bring it down in front and have 2 times log of x, and that is true. On the right hand side though, log x quantity squared means log of x times log of x, and those guys are just not the same. So for example, if we have log of 5 squared, that's not going to give us the same value of log of 5 quantity squared. So I'm going to drop the 2 down in front and find the value of log of 5 and then multiply it by 2, and then I'm going to find the value of log of 5 and square that value, and notice those are not the same. Alright, let's take a look at number 3. So number 3 says that the log of b, the log of 10, and the log of 7 added together with the same base is going to give us the log of 17. And that is not the case either. We know that we have a product rule that said if you have 2 bases that are the same, you can go ahead and take the product of what's inside. And so 7 times 10 is going to give us the log base b of 70, which is definitely not going to be the same as the log base b of 17. Those are 2 absolutely different quantities. All right, moving on to number 4. I see this a lot. For example, the log of 15/8. People might rewrite that as the log of 15 over the log of 8, which is definitely not something that you can do. And I often see people trying to cancel out the logs, and that's also not a thing. So none of those are good things to do. So remember, if you are 15/8, you're actually inside of the log. Here's like part 2 of that. If you actually had the log of 15 over the log of 8, you could use the change of base rule, and you could write that as the log of 15 with a base of 8, log base 8, 15. So those are equivalent statements. So that you can do, and that's called change of base. So just make sure that you understand when you're using the change of base rule. Okay, and that's going to be true of any base of logs as long as those bases are the same. So I put little green bees there. All right, the next rule, number 5, again, violation of fractions of logs. So a lot of people I see, if I'm giving somebody like, for example, the log of 25 over the log of 5, they'll try to cancel out the fractions in there, and you absolutely can't do that either. So even if you did, you would have the log of 1 in the denominator, and the log of 1 is 0, and you shouldn't be dividing by 0. So that's definitely not something that we should be doing. Again, let's go back and think about using the change of base rule. You have two logs, they have the same base. We should be able to rewrite this using the change of base right there. So, and that's fine. And if I rewrote 25 as 5 squared, now I know that the exponent and its log are inverse functions of each other, and so they should cancel, and I should just get out 2. So ultimately the log of 25 over the log of 5 just gives me 2. All right, moving on. Sometimes when it comes to solving, for example, if you wanted to solve 2 to the x equals 40, and people know that, okay, I need a log to bring that x down in front, they'll log both sides, but they'll write it this way, which is not good. Because remember, if you're taking the log of something, it's the log of 40, not 40 times the log. That's not what we're doing. So more properly, if you wanted to solve for this, you're going to log both sides like that, so that somebody sees that you're taking the log of 2 to the x, and that's going to be equal to the log of 40. So that's much more proper to write it that way. And if you wanted to add in those parentheses, you could. Continuing to solve, I'm going to drop the x down in front, which was the whole purpose of taking the logs. I'm going to divide both sides right there so I can isolate the x. And remember, do not cancel the 40 and the 2. Do not cancel those two logs. You could rewrite it as a change of base, or at this point you could just find those two values and solve. Okay, so that would be great. And then finally, take a look at this one. What do we think? Is this true? Is this okay? Is this a mistake, or is it legit? Right? So, and yes, it is agreeable. That's totally fine to do. So, for example, if we used the product rule and we have two logs that are being added together and they're the same base, we could take the product of 4 times 4, which gives us 16. And then I'm going to rewrite log of 16 as log of 4 squared, and notice where that 2 could go. It could go right down in front, and now I get 2 log of 4, and yep, that does equal 2 log of 4. So that was not a mistake, that was actually legitimate. So hopefully this helps, and hopefully you can prevent some mistakes from happening to you when using logs. And let me know if you need anything, or if you have any comments, or if you have any requests.